8.5, folks. So we understand the game, and now they're like, okay, let's just divide stuff. We were just multiplying things, so now we're just going to divide things. No big deal. 246a, radical 48, or radical 48 over radical 75. So 48, again, I'm going to do it fancy way. I see that 16 is in there, so that's rad 16, rad 3. And rad 75, I see 25 is a perfect square in there, so rad 25, rad 3. That gives me rad 16 is 4, rad 25 is 5. And then here's the big idea of this section, rad 3 over rad 3. Bye-bye. Easy peasy. 4/5. So they're just combining everything we know. B, cube root of 81 over the cube root of 24. Again, I know my cube roots pretty well. If you check out, I think it's 8.1. They have the list of all the cube roots, or you could just keep breaking it apart. But I'm going to write this as the cube root of 27 times the cube root of 3. 3 times 27 is 81. Cube root of 27 happens to be 3. Do I recognize any cube roots in 24? Yes, 8. Leaving me, see, 8 times 3 is 24. So I guess I could cross these out right now. Cube root of 27. See, I guess I could have done it right here in the previous problem. So we have, where are we at? Cube root of 27 is 3. Cube root of 8 is 2. Ta-da! Let's try 250. Oi. 250. A. Square root of 196. That's a perfect square. 14 times 14 is 196. Over 484. Ooh. 484. Q to the 5th. Oh, now I recognize 484. It looks similar to 121, 11 squared. So this is just, let's see, let's clean this up. 196 is 14, and then square root of Q doesn't clean up. And then 484 is rad 4, rad 121, Q to the 5th. So it's a square root, right? There's a little 2 here. So how many chunks of 5 can I take out? 2. And who's left under? Just one of them. Make sure that makes sense. So the square root of Q to the 5th becomes Q squared root Q. Make sure you're cool with that. Okay, so this gives us, I guess we could cancel out those rad Q's. So that's a 14, and then that's a 2, and that's 11, so 22 Q squared on bottom. Oh, they're both even, so I guess we keep going. 7, 11, so 7 over 11 Q squared. Whew. Okay. 250B now. That was part A. Uh-oh, that's not a good piece of paper. B. $250B. Cube root of 16 m to the 4th all over cube root of 54m. Okay, so that's the cube root of 8, cube root of 2, and then it's a cube root. It's m to the 4th. We're taking things out in chunks of 3, so one of them escapes, one of them does not. Downstairs, I went with 8 and 2 because cube root of 8 is 2. 54, I recognize 27 is in there. Cube root 2, 27 times 2 is 54. This will turn into a 3. Okay, cube root of m. How many escape? None, so there's just a cube root of m. I guess I could just get rid of these right now get rid of these right now. Cube root of 8 is 2. There's an m sitting there. Cube root of 27 is 3. Ta-da! I'm going to do 252b. 252b. Skip part 252a, because that one you could totally handle. 252b looks interesting. Cube root negative 375, y to the 4th, z to the negative 2, all over cube root 3y negative 2, z to the 4th. Let's see if I wrote it down right. Negative 375, y to the 4, z to the negative 2, 3, y to the negative 2, z to the 4. Okay. Ugly looking problem. Cube root. I see that 125 is in here. 125 is 5 times 5 times 5. So, let's break this apart. Oi, oi, oi. Cube root, cube root. Trying to figure out the best way to attack this problem. Maybe, sometimes, okay, let's do this. Let's just call it a big cube root. This is probably what the book does. Probably should have read the book. Negative 375, y to the 4th, z to the negative 2, all over 3. Yeah, this is what the book would do. Y to the minus 2, z to the 4. Yeah, so we have a fraction, and now we can kind of clean things up. So this is the cube root of, let's see, the 375 over 3 is negative 125. Y to the 4th upstairs, y to the negative 2 downstairs. So that's negative 2, bring it upstairs. Make sure you're cool with this. Y to the 6, yeah. Negative 2 upstairs, bring it down. Z to the 6 downstairs. Aha. So that's going to give us the cube root of negative 125 is negative 5. The cube root of y to the 6, how many chunks of 3 can you take out? 2. Z to the 6 downstairs, how many chunks of 3 can you take out? 2. Ta-da! Okay, then. Then. Okay. Then they do this thing called rationalizing the denominator. So, remember, you're not allowed to leave a negative downstairs. It's bad manners. Well, you're not supposed to leave a radical downstairs either. It's bad manners. So 260a, we have 8 over the square root of 3. So you're not supposed to leave radicals downstairs, so they call this rationalizing the denominator. How do we get rid of that radical downstairs? So here's the trick. We're going to multiply by a form of 1. So what if I multiply by rad 3 over rad 3, right? That's just 1. So notice what happens to the bottom. What's rad 3 times rad 3? It's just 3. And so maybe you said, oh, rad 3 times rad 3 is the square root of 9. What's the square root of 9? 3. Oh, it's much easier just to think of the radicals canceling each other out, square root signs. And then upstairs, 8 rad 3. Aha! So is the downstairs, the denominator clean? No radicals? Yeah, we're done. Okay. B. Radical 7 over 40. So we should call this radical 7 over radical 40, first step. And let's clean this radical 40 up. So we have, that's going to give us a radical 7, and I see a 4 in there, so that's radical 4 times radical 10. And so radical square root of 4 is 2, radical 10. Okay, now we're sort of like we were in the very beginning, question A. We've cleaned it up as much as possible. Here's my final answer. Oh no, you can't leave radicals downstairs. Okay, let me clean it up. There's a radical 10 downstairs, so let me just multiply by rad 10 over rad 10. Boom. And then what's rad 10 times rad 10? 10 times 2, 20. Rad 7 times rad 10, rad 70. Aha. And then I put C right here. C It says 8 over square root of 2y. Okay, no radicals downstairs. What's downstairs? A radical 2y. How do I get rid of it? Multiply by rad 2y over rad 2y. Yeah, that easy? Yes. What's the bottom? Don't overthink it. 2y. Aha. And top? It's 8 times radical 2y. And it's done. Boom. Hubba, 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 hubba. Ugh. Okay. Oh, eBay. And then it gets a little tricky for a second. Okay. And by a little tricky, I mean kind of tricky. 264. So square roots, that was all making sense, right? And then in 264a, here's where it gets weird. Cube roots, or fourth roots, or fifth roots. They do third roots and fourth roots. A cube root. Oh, you're not allowed to leave radicals downstairs. Okay. So what could I multiply by to get rid of this? So again, you need to know your perfect cubes. Well, if it's 3, then think of 3 times 3 times 3. Oh, square root of 20, cube root of 27 is going to make clean up nicely. So what if I multiply by the cube root of 9 over the cube root of 9, right? Same trick, multiply by a form of 1. And look what happens to the bottom. That's the cube root of 27, which is just 3. Multiply across, cube root of 9. So you have to actually think now about what goes here. Because if it's a square root, right, then it's just real easy. But if it's a cube root or fourth root, you gotta stop and think about it. So we have cube root of 5 over 32. I'm going to call that the cube root of 5 over the cube root of 32. And then, are there any perfect cubes? There's a couple ways you could do this. Let's clean up cube root of, can we make the bottom a perfect cube? 4 times 4 times 4 is 64. So the goal is to make the bottom a perfect cube so that there's no radicals. So what if I multiply by cube root of 2? Remember I was saying it's complicated to figure out what you multiply by? Because look what happens to the bottom. It becomes a cube root of 64. And what is the cube root of 64? 4. Because 4 times 4 times 4 is 64. So again, figuring out what to multiply by is tricky. 264C. 7 over cube root of 49B. Okay, maybe this will help us see it better. 49 is 7 times 7, right? 7 times 7 is 49, but if it's a cube root, let me multiply it by another 7. The cube root of 7, and there's just a b here. I need there to be 3 of them, so let me also multiply by a b squared. Cube root of 7b squared. So the bottom becomes 49 times 7. Well, who cares? It's 7 times 7 times 7, so it just becomes a 7. And there's a b and a b squared, which is a b cubed. And what's the cube root of b cubed? B. And upstairs we have the 7 times the cube root of 7b squared. Tricky. Redo all 3 on your own. Make sure you can get the same answers I did. But yes, pretty tricky. And then more? Yes, more. So those cube roots are tricky. But then next they, instead of just one thing downstairs, they have a binomial. But that's not bad. How long is this video? 15 minutes so far. Okay, remember we always talked about conjugates. Conjugates. So 272, you have 7 over 2 minus rad 6. Okay. Radicals are not allowed downstairs, so what do we need to do? Oh, there's two pieces. It's a binomial. No big deal. I'm going to multiply by the conjugate, 2 plus rad 6. And if I multiply the bottom by 2 plus rad 6, I multiply the top by 2 plus rad 6. Multiplying conjugates is easy. You FOIL them, but outsides and insides always cancel because they're conjugates. So it's easy. 2 times 2 is 4. Root 6 times root 6 is 6. And then up top, we just have a, just distribute it. Or maybe don't distribute it. We just have a 7 times 2 plus rad 6. It's all over negative 2. You're not allowed to leave negatives downstairs, so instead of 7, 2 plus rad 6 over negative 2, so 7, 2 plus rad 6. Instead of over negative 2, you can put the minus sign on the fraction bar or on the negative 7. I think it looks prettier on the negative 7. So you're not allowed to leave radicals downstairs. You're not allowed to leave negatives downstairs. Boom. Okay. That was not bad. 276. Radical 5 over square root of n minus rad 7. Oh, there's radicals downstairs. No big deal. I'll just multiply by the conjugate, rad n plus rad 7. Multiplying conjugates, is that easy? Yes. Rad n times rad n is n. Rad 7 times rad 7 is 7. Oh, okay. I guess that was pretty easy. Show my work. Ta-da! That's it. Okay, cool. So you should be able to now handle 8.5.